Reassessment number 4, Kinetics. So Luke Skywalker is on a speeder bike, escaping from Endor's woods with a velocity of 200 meters per second and can accelerate at a maximum rate of negative 10 meters per second squared as it comes to a rest. A. From the instant it escapes the woods, what is the minimum time needed to stop before going over the cliff? B. Can Luke's speeder stop in time before going over the cliff and into a ravine that is 0.8 kilometers away? C. What are the components of the speeder bike going over the cliff? D. If the cliff is 300 meters high, when will the speeder bike reach the bottom? And E. What is the total final velocity of the speeder bike after it has left the cliff edge? Find magnitude and direction. So, we draw a picture. We know acceleration is negative 10 meters per second squared. It's going 200 meters per second, and velocity equals 0. So the the V final part equals 0, and it's 300 meters high. Now, the minus sign automatically indicates that it's slowing down, not that it's speeding up. So T equals velocity final minus velocity original over A, or 0 minus 200 over negative 10, equaling 20 seconds. So it takes 20 seconds for Luke to stop. The speeder travels the shortest distance in stopping if its acceleration is negative 10.0 meters per second squared. With x original point equals 0, the speeder's final x coordinate is found using the equation x final equals x original plus 1/2 v original plus v final change in time, or time change in time, excuse me. So you just plug in everything in. So your x final equals 0 plus 1/2 200 meters per second squared plus 0 meters per second squared times 20 seconds. That comes out to 2,000 meters or 2 kilometers. So Luke's speeder bike is unfortunately going to fly out of the woods and right over the edge of the cliff into a fiery doom before he can stop. But Luke is a Jedi, and so he can use a different kind of force to leap from the bike before it goes over the edge of the cliff and to safety. And so there he is standing on the edge of the cliff while watching the speeder bike crash to its fiery doom. Now, since there is no downward velocity, the y velocity equals 0 meters per second. The x velocity can be found using the same equation from above. We know that x final velocity plus xo plus 1/2 vo plus v times change in time. Once again, we just plug and play. So 2,000 meters equals 0 plus 1/2 times 200 plus v times change in time. And now change in time is still 20 seconds. Now v equals 2 times 2,000 meters minus 200 meters over 20 seconds, or 190 meters per second. Now you take the 190 meters per second from the original 200 meters per second, and that can give you your final velocity in x vector, which is 200 meters per second. 10 meters per second. Now, part D. We know the height is 300 meters. We know that y is found being 1/2 gravity times time squared plus the velocity in the y axis, or the original point, times time. And that's 0 because that's the original point of y is 0. So h equals y equals 1/2 gt equals 300 meters. So 1/2 times gravity times time squared equals 300. And you just switch each side, so you get T2 equals 2 times 300 over 9.8 meters per second squared, or 61.22 seconds squared. Excuse my hand shaking. And that is time equals square root of 61.22, or 7.82 seconds. Now the total velocity. The total velocity is just kind of like the Pythagorean theorem. Actually, it is the Pythagorean theorem, but we find out what each component is. So the velocity of the y the final velocity, is gravity times time plus the y original point. And the y original point was 0, so it's 9.8 times 7.82 plus 0 equals 76.68 meters per second. X is just 10 meters per second. So you take the square root of 10 plus the square root, sorry, not square root, you take the power of 2 of 10 plus 76.68 squared, and you add them together, then you take the square root of that, and you get 77.3 meters per second. So, and then to find the direction, you take the tangent, the negative tangent of 76.68 over 10, you get 82.57 degrees below the horizon or southward. Thank you.